Moving on from the work that you've done on rounding, we're going to start a new topic for today that's called bounds. This is basically reverse rounding. This is where you're going to be given a number that's been rounded, and then you're going to figure out what the maximum and minimum possible values could have been before that number got rounded. So I'm going to show you a couple of examples on either side of this, and then you're going to have a go at some of these yourself that's very similar. So looking at this one on the left, you've got 3,000, but that's been rounded to the nearest thousand. So there's been some number that you've started with that might not have been 3,000, and then it's been rounded to the nearest thousand, and that's the answer. And what we want is the upper bound. What this means, this is the maximum possible value that your number could have been before it got rounded down to 3,000. So to help us do this, I'm going to draw a number line, and this is going to help me with all three parts of the question. And then because 3,000 is what I've rounded to, I'm going to put that in the middle. And then because we're rounding things to the nearest thousand, I'm going to go upwards and downwards by a jump of 1,000. So the next 1,000 up from that is 4,000. And the previous 1,000 is below, which is 2,000. Okay, so when numbers round to the nearest 1,000, they're going to go to one of these three numbers. So to figure out the upper bound, we said it's the maximum possible value. We're going to be looking at the top portion of the picture to see what the maximum value is I could have that still rounds to the middle. So if my numbers that I choose are close to the middle here in this region, I'm going to be rounding to the 3,000 because it's close to that. If I choose a number that's towards the top end in this region, I'm going to be rounding up to the 4,000. So it looks as if the boundary for where you start to round either way is going to be in the middle here. So I'm going to put in the middle the number that's halfway in between, that's 3,500. Okay, now that's gone in the middle. If I'm to the left of this red line, then that means I'm going to be close enough to the 3,000 to round down to this one. If I'm to the right of this line, I'm going to be rounding up to the 4,000 for the same reason. So that number there is what we take as the upper bound. Okay, I'm going to write UB for upper bound. Okay, now you've also got to think about what would happen if you were actually this number. If my value was 3,500, then you wouldn't round to 3,000, but you'd round to 4,000. But we still take this number to be the upper bound, because if I choose any number that's any smaller, if I was to pick 3,499, for example, then I'd be leaving a gap between this number and 3,500, or I could still fit more possible values of my number. So we take 3,500 to be the upper bound, even though we're not allowed to be that number. And that's part A done. For part B, if I want the lower bound, it's the same idea, just on the other piece of the picture. So down here, on the low values, I want to not be rounding to 2,000, but I want all the numbers that round to 3,000. The boundary is again going to be in the middle. So put a value here, and that's going to be in between 2,500. And that's going to be my lower bound. If I'm to the left of this line, I'm going to be rounding down to the bottom end. If I'm to the right of this line, I'm going to be rounding into the middle at 3,000. And if I am 2,500, then that value rounds to 3,000 as well. So a little bit of a difference. It's still the lower bound, but this time I can actually be this value. So 3,500 is the answer to A, 2,500 is the answer to B. Now, if I want the error interval for part C, what that means is I want to write an inequality that describes the range of values I could possibly have and collect all of them together. So what I'm going to do, I'm going to use X for my possible values. This is going to represent all the possible answers I could possibly have and started with. Then my X is going to sit in the middle like this. And we're going to describe the upper bound. My X values, they have to be less than this value up here, 3,500. So I'm going to put less than 3,500. Okay. And then we're not going to put a line underneath our inequality symbol because we're not allowed for our X to be 3,500, as we said, because that would round upwards. But on the left-hand side, my X value has to be bigger than the lower bound down here. So I'm going to put another inequality symbol to show that X is greater than the lower bound, which is 2,500. And this time I've put a line underneath my inequality to show that my x can in fact be this number here. It just can't be this one. And then that's how you write your error interval. This is the upper bound at the top, lower bound at the bottom, and the lower bound is the one that gets the line underneath because that's the one that you're allowed to be. And that one's finished.